In this video, we're gonna give the final touches to our structure before the analysis, and for that we're going to cover many important features such as how to fix or establish the fixity at the ends of the bars, how to deactivate self-weight loads and surface loads automatically generated, how to move panels that carry surface loads, how to establish the deflection limits, the backplane and lateral backplane factors, and how to add additional load cases and loads. We're going to start by the fixity at the ends, and for that, continuing with the sequential order, we are going to move to Properties menu. Here we find most of the features that we're going to comment in this video, such as pin and fix. The difference between the two tools is that fix is our more advanced tool, or we say more advanced because if we go to establish the fixity at the ends of, for example, this bar, we're going to have the control over which planes we are fixing or pinning, and up to what grade of pinning we're going to have. So 0 meaning pinned and 1 complete meaning completely fixed. We could establish a value in between 0 and 1 and establish them by plane. So of course, in the origin and in the end of the bar, we have control over which plane and in what type of fixity we want to have. The other tool, which is the one that we're going to actually use in this example, is the pin tool. In this case, pin makes the end that we pinned in every plane. So we do not get to choose in which plane, we just choose in which end. And it will be completely pinned, not a value in between 0 and 1, just completely pinned, meaning 0 fixity coefficient. So if we zoom in, we can see that if we click somewhere in the middle of the bar, the software automatically pins both ends. If I zoom in this other bar, for example, that we also have to pin, if instead of clicking in the middle of the bar, we click more towards one end, we will have control over which end we're pinning, but just that, not of what value nor what plane we're pinning. And in our case, all these 4 bars that are part of the BIMs2 tag should be completely pinned. We're also going to pin the braces in the roof. So for that, we're going to move to the 2D view window that we created for the view, for the roof. And before we pin the bars, there's one thing we have to comment first. I have made a copy of the structure and I have it in a parallel window. By the way, this is possible in the software. If we have a CYPE window already active, if we click again in the CYPE access, it will open a parallel project and we can work in both at the same time. So let me speak about one tool that we skipped in the last video and that we could have used when introducing the braces, and that is the generate nodes at intersection points. So right now, the angle sections that we inserted for the braces are their length is from this node, in this case, to this one, so full bars. We, instead of inserting it without that activated, we're going to activate to see the difference. And when we go about inserting a bar with this tool activated, what we find is that whenever there's an intersection, the software automatically creates a node. So in this case, these bars are still, it detects them as an element, full element, but at least they have a node in the middle. We inserted them without this tool activated, so the way to fix it in our project is going to be by inserting a node in their intersection. So this is now something that we do have to do in our project is geometry, new node, and clicking in the midpoint of those bars. And to separate the bars into 4 pieces, we already used this tool. It's called Element. So we click in Element and we go about creating just individual bars until the intersection. Okay, this is how we wanted them to look, the braces, before we pinned them. And now we're going to pin them with the same tool that we used before. So it's pin ends here in properties menu. And by clicking in the middle of the bar, we make sure that the circles of the pinning come up, but both ends shall be pinned. And speaking of the braces in this structure are going to have a very specific function, and for them to work only for in tension, we are going to free them from their self-weight and the loads from the panel. First, let's free the braces from the automatic generation of self-weight loads. So in the load menu, we find these bars self-weight, and we click in deactivate and we choose all 8 bars that form the braces and confirm with a right click. We can tell that they are now freed from the self-weight because every other bar is sort of orange toned, and now our bars are completely gray. We can also deactivate the there's a panel that came from Portal Frame Generator carrying the weights of carrying the loads of the wind, and this panel distributes the loads in the direction that is now displayed on screen, horizontally in this case, and that affects our braces unless we do something about it. So the loads, we want them to be carried by these beams, but not our braces. So to free them from the surface load of the panel, we have this tool called Assign. And when we click here and select the 8 braces, and with a right click, we free them from the loads. There's double check that we can do, and that is by going to the analysis menu, clicking in issues, and there will come up an information symbol that says that the automatic generation of self-weight loads has been deactivated for these bars. Now, speaking about our panels, we're going to stretch the panel because we inserted, remember that we inserted in the frame a few bars that didn't come from Portal Frame Generator. We added them afterwards. So we're going to stretch the panel, and that is going to be done in the load menu, the panel options, and move. And the way to operate this tool is to select the panel with a click. Then it says select the vertices to move. So we select, for example, these 2 points, confirm with a right click, and then we have to select the point that is going to be taken as the reference of the displacement, in this case this one, we move to select the next point, which is going to be our final destination, and we click on the right click on the mouse to confirm. And that way the panel now covers also those bars. Let's do the same thing. We click in the panel, we select the two vertices that we want to move. We'll confirm with a right click, and now we choose the point of reference and move it to the final destination. There's one important thing to comment about this possibility to stretch panels, and that is that if the variation, the editing that we do after coming to Site 3D from Portal Frame is too big from Portal Frame, the loads, what the stretching does is it has stretched also the loads to cover, let's make visible healing loads, visible load case, the wind load that the panel was carrying. So we now see that also these edges that we created are carrying the wind load. But if we had consulted the values of the load before we had done the stretching, we would have been able to see that the values have not changed at all. And that might not be completely correct. In this case, it's a very small difference. So, and the structure is very small, so it doesn't really matter these other values, but just pay attention, please, because if the geometry it varies too much from the portal frame generator, maybe the wind loads generated won't be useful anymore. Okay, let's hide the issues by clicking analysis again and issues, so that disappears. And now that we have talked about move panels, it's time, according to our contents, to talk about deflection limits and backplane and lateral backplane factors. For that will also be found in property menu. So let's talk about the deflection. Here we can establish the limit and limit the deflection. In our case, we're just going to do it to demonstrate afterwards in the results. In this case, we're not placing any fragile object on top of any of these bars, so the deflection in this case might not be very important, but we're going to limit at least one distal bar of the frame to see some results when we come to the results video. In this case, the limiting deflection is available for absolute and relative values. Relative meaning in relation to the longitude, the length of the bar, and maximum absolute being the absolute value, and maximum and active. We can click here in this book icon to access the help to know that the maximum deflection is the maximum absolute deflection value, and that the active reflection is the difference between the maximum and minimum deflection. So here we can have a help of what is each one, and so we can know what we want to establish. In this case, we're going to limit the relative maximum deflection in the XZ plane, so this one, and we're going to limit it the length divided by 300. Just remember when we go to the results that this is the bar that we limited the deflection for. And it's now time to speak about the backplane factors. Backplane and lateral backplane are both checked in the software, so we can establish the values by hand by clicking in backplane and selecting the bar. But there are two options to help us with this. As you can see, we haven't done any work on the backlink factors so far, and yet we have some backlink coefficients that differ from 1. That is because when we were exporting from Portal Frame Generator, remember that we selected that we want them to be in backlink in sway frames. So it has helped us with the bars that came from Portal Frame Generator. It's true that in this case, not many bars are going to be in danger of backlink, just the bars with compression forces, and that might be just the columns in this case. So no need to limit any other bar. But just note that the software CYPE has also a more advanced tool to automatically or analyze the backlink, so we can then obtain the backlink factors. That would be a more advanced topic, and we're not going to cover it in this training, but please just know that the options to take it into consideration in the bars would be here: update the backlink coefficient in whichever plane and consider them in backlink analysis, and that the backlink analysis can be found at the analysis tab, and we have a full menu for it specifically. Plus, if you are interested in training in that backlink, please search in our webinars in the learning resources of CYPE for nonlinear analysis and backlink analysis, because there have been webinars where we have covered these topics. So coming back, same thing happens to lateral backlink. Remember that we said in Portal Frame Generator that the part lengths were going to have 1.3 separation. So that's exactly what the CYPE has come with from Portal Frame. It knows that the top flange is going to be in contact with those part lengths, and that the separation between the bracing is 1.3 meters. Okay, now that we have commented the limit deflection and the backlink, we are going to move to the final part of this video, which is creating new load cases and adding loads. The first thing we have to do is create the load cases. So for that, we have to come to project and general data, and we find the possibility of additional load cases. Here we find the ones that are already by default or by coming from Portal Frame, which have been self-weight, 2 wind load cases, and 1 snow load case. But we are going to create, for now, 1 more, and then afterwards we will create even 1 more live load case. So we have to select the use category again, domestic and household. And we are going to click here in add and just go by the reference that the software gives by default. And live load 1, accept. And now that the load case is created, we can attach loads to that load case. So let's demonstrate that. Coming back to the roof, we could say that this roof, besides the self-weight and the wind loads, we can have some light loads on it. So to add a load in the entire surface of the panel, we would have to do it by panels, edit the panel, as we're going to do because it's actually our case. But just know that to create surface loads that don't cover the entire surface, we have the tool to create new surface loads. So the difference is that we are going to edit the panel and we're going to add a load in its entire surface. So we're going to click in Panels, Edit. We're going to edit the panel with a right click. We can confirm. And now that we go about entering a uniform load, we're gonna click in Add. And since we have created previously, we will have available the live load 1. And let's check the units that this Site3D project is working with right now. I can see or check by placing the cursor over value, and I can see it's in kilonewtons per square meter. That's the one that I want. I'm going to establish a 1 kilonewton live load in this roof panel. So I'm just gonna add it like the live in kilonewtons per square meter, 1 kilonewton. And I'm going to click accept. Just in case the units in that column weren't the same as mine, just remember that clicking here in configuration, one can find the unit setting, and mine is in International System of Units, 1 kilonewton per square meter. Now we're going to add, this is the final part of the video, we're going to add a load in this bar. Let me demonstrate in the 3D view. Let's somehow hide the panel. By the way, besides the tags that we create, the software already has its own tags. They're called categories. So we can hide by element, type of element. So for example, I could choose to make non-visible the panel right now, and the bar that we're going to apply the loads to, it's going to be this green line right here. And for that, we're going to create a new live load case. Coming back to project general data, the difference is that when we go to create it this time, we're going to create a load that is going to have different dispositions. So if we click here in different dispositions, the load that I want to apply is going to simulate some type of crane that could stop at different points of that green bar that we were taking. So it's going to have 3 different dispositions, and since the crane in this case can either be in 1, 2, or the 3rd position, we are going to make this incompatible between each other. So this means that the crane cannot be in 2 places, in 2 dispositions at the same time. I'm going to click accept and click accept again a few times, and now we can go about inserting it. When we come to loads, these type of loads that we're going to create are going to create in bars. So we're going to click in create new loads in bars, and always have the tallest part of our structure to our left. In this case, this is the tallest part, and this is the shortest. So just to know which bar I'm selecting right now is this one. The load is going to be attached in this first position. It's going to be a point load of 20 kilonewtons of value, and it's going to be a vertical gravitational load. So it's going to go in the according to negative direction of z-axis, and this relative position allows us to insert it either in one end, the other, or somewhere in between. In this case, we're going to place the point load in the middle. So we're going to say distance is relative distance. So 0 meaning the start of the bar and 1 meaning the end. This is the mid position. To display the load that we have just inserted, we're going to click here in Visible Load Case and choose to display Live Load 2 in position 1. So we can now see here in the middle of the green bar the 20 kilonewtons that we just added. Next up is going to be again in the same bar. It's also going to be attached to the same load case, position 1, point load of 10 kilonewtons, also applied in the middle of the bar, 0.5, and this time we're going to select that it's going to go in the positive direction of the x-axis. We can either go by the global axes of the global axes of the project, which by the way are right here in the bottom left corner of the work area, always displayed, or we could choose to establish the direction of the load by local axes of the bar. And how do we know which are the local axes of the bar, or which end is the start and which is the end? Well, we can know that by coming closer to the bar, activating here in the toggle menu the view options displayed the local axes. So we can see that for this green bar in which we were inserting our loads, the positive direction of the x-axis is this red arrow pointing to the left, and this way we can tell that in this bar, this right end is the start of the bar and this left end is the end of the bar. This is important for the next load that we are inserting. Same thing goes for the bar in which we're going to insert it, which is the following green line, the green bar, and their local axes are exactly the same. So we know that in this case, this node, let me select it. This node is the start of the bar, and this other node is the end of this green bar. So again, new load. This time we select this bar to the right, and we're gonna change positions because I want to contemplate the possibility of the crane stopping right at the middle. So or hitting the middle bar right here. And for that, we're going to choose the second position possible for the crane. And we're going to establish a 3 kilonewton, this time in the end of the bar, 1, because we saw that in this bar, this is the end. And in global axes, we're going to express that this load is going to be horizontal and in the positive direction of the x-axis. If I make it visible load case and position live load to position 2, I can see right there the 3 kilonewtons acting in this point. And lastly, we're going to add 2 more loads in this right bar. Both of them are going to be in position 3, point loads both. The vertical one is going to be 20 kilonewtons applied in the middle of the bar, and it's going to go by the negative direction of the z-axis. And our last load is going to be also in that same bar. Same position, 3, point load of 10 kilonewtons in the middle of the bar, so 0.5 of relative position, and this time is going to go in the negative direction of the x-axis. And we can see them right there applied.